All right, number 14, we have two trains left the same station at the same time. Train A travels north at 28 miles per hour. Train B travels south at 52 miles per hour. How much time has passed before they were 320 miles apart? All right, so for these related rates problems that involve distance, rate, and time, right, we're given a distance, 320 miles. We're given rates, 28, 52 miles per hour. And we're given times, um, they leave the station at the same time, and so we want to find the time. So time is a variable. I like to set up a table, and it also doesn't hurt to draw a picture. So I have my train going north, all right, and it's going at 28 miles per hour. So 28 miles per hour, and I have another train going south, which is 52 miles per hour. So to just kind of make sense of this, and you probably could do this with a pattern for this particular problem. I'm going to show you how to do it with an equation in case the numbers don't come out as nicely. All right, if we were to do like a little like frame by frame, all right, at 0 hours, both trains are at the same spot. All right, at 1 hour, one train is 28 miles this way, another train is 52 miles this way, so they're 80 miles apart. All right, at 2 hours, now this train is 28 times 2, 56 miles this way. The other train is 52 times 2, 104 miles this way. All right, so now they're 160 miles apart. So you kind of see every hour they're getting 80 more miles apart. So if you do it that way, all right, if they're getting 80 miles apart every hour, it's going to take 4 hours for them to be 320 miles apart. All right. So sometimes if you approach it like that, you could find your answer right away. And this doesn't work every time, but at least now we understand what the problem's asking. All right, so now I'm going to make my table. All right, so distance, rate, and time. And I like to do this because it's like an organized way to approach these problems. Okay, so each column is going to be distance, rate, and time, and each column is going to be like a different thing moving. So this is going to be the train going north. This is going to be the train going south. All right, the distance is equal to rate times time. So I don't know their distances, so I'm going to call this dn for the distance of the north train from the starting point, and this ds, the distance of the south train from the starting point. So like after 1 hour, ds would be 52, and dn would be 28. After 2 hours, dn would be 56, ds would be 104. All right, the rates are given. The rates are given as 28 miles per hour and 52 miles per hour. Now, it's really important that you pay attention to the units, because if you're using miles per hour as your rate, then your time has to be in hours and your distance has to be in miles. And you could change these units, but you have to be consistent or else you're going to run into issues. All right? And then time, all right? Time is the time that's passed from when it started. So since they leave the station at the same time, I could call both of these t and let t be in hours, and t equals 0 is when they leave the station. All right, now in this problem, we actually have three variables. We have t, which is the time how many hours have passed since they left the station, and we have dn and ds. And if we're solving the system, we actually only have two equations right now. dn equals 28t, and ds equals 52t. So that's a system of three variables, two equations. That's not enough information to solve and get a specific point. So you have to come up with another way to relate these, and it's going to go, and if you notice, we haven't used the 320 yet, and that's how we're going to relate these. All right, this is the north train distance, and this is the south train's distance. What we're looking for is when that total distance adds up to 320. So our final equation is going to be the distance of the north train plus the distance of the south train equals 320. And this system is pretty easy to solve without a calculator. What you could do is just substitute 28n in for dn, substitute 52t for ds, all right, and then you get 28t plus 52t is equal to 320, 80t is equal to 320, and then t is equal to 4 if you divide both sides by 80. So in 4 hours, like we checked out earlier, that's how long it'll take for these trains to be 320 miles apart. And the only variations of this, a lot of these problems are similar to this, but other variations would be like if the trains left at different times, and you would just adjust this. Let's say the south train left a half an hour later than the north train. Well, then I would just make this t minus 1/2. All right. Or maybe the trains are going in the same direction and you want to know when they've caught up to each other. Well, then you would just set the distances equal because when their distances, if one train leaves earlier and the other one's going faster and you want to know when they've caught up, that's when they traveled the same distance. All right. So there's different variations to this. This is one basic setup you can use for these related rates problems.